All right, my Math 2 people, here we go. We got lesson 10-5, solve using square roots. We're going to take quadratics, and we're going to find a method for solving them. Our question today is, how do you know if the equation does not have any real roots? What's a real root? I don't know. We'll get to that. So anyways, we've got three terms up here that all mean the same thing. Your x-intercepts, your roots of an equation, and your zeros of a function, they all mean the same thing. We're talking about the solutions of a quadratic function when x or when y equals 0. So remember, a quadratic function is when the highest term has an x squared. So anyways, so we're going to make y equals 0. Now there's going to be three possible outcomes because remember, these are the x-intercepts. A couple lessons ago, we talked about when we could have two solutions. So if we've got a graph there and we've got like a parabola crossing that graph twice, we would say that there's two x-intercepts. Well, that means that there's two solutions to the equation, which also means there's two roots of the equation, which means there's two zeros of the function. All three of these mean the same thing. The other possibility that we mentioned is that it's possible to only get one answer. So if I've got a parabola where the vertex is on the x-axis, I would have only one x-intercept. Well, if I only have one x-intercept, that means there's only one root to the equation, which means there's only one zero of the function, which means a solution, there's only one solution. So we can have two solutions. That's when our parabola is crossed the x-intercept twice. And I can get one solution. That's when our vertex is on our x-axis. And we only have one answer. And then, of course, it's possible to not have a real solution. Now, we say real solution because we're going to get to something called an imaginary solution in another unit. So we're going to call these no real solutions. There's always a solution, but sometimes the solution isn't actually real. I know it sounds weird, but it's a real thing. Anyways, so we'll notice that this one right here, it doesn't cross the x-axis. So that means there's no x-intercepts, which means there's no roots of the equation, which means there's no zeros of the function. Basically, there's no real solution. We're going to use that word real because eventually, like I said, we're going to get to imaginary solutions. It just sounds like I'm making up stuff at this point, but it's real. I'm not making this stuff up. All right, so we are going to solve using square roots. Well, the first thing that we want to do is we want to isolate the x squared. So in order to isolate this x squared, I'm going to add 9 to both sides of the equation. Pretty simple. Added 9 to both sides. What do I got now? Well, I've got x squared equals 9. You might be getting excited at this point. You're like, ooh, I know the answer's 3. Well, not really. That's one of the answers. This situation is where we're going to get two answers because not only will 3, when you square it, give us 9, but also negative 3 will give us an answer of 9. So when we take the square root of both sides, stupid lights. Come back on. It's killing me. Seriously? It's the worst room ever. All right, so anyways, if you take a square root from both sides, because that's how we're getting x by itself here, so I'm taking the square root from both sides because the square root is the opposite operation of squaring. So if I take the square root of both sides, I have to realize that there's actually two different possibilities. Because squaring makes a negative into a positive and keeps a positive as a positive, there's always going to be two options, two solutions. And so what we're going to do is we're going to add this plus or minus sign anytime we take the square root from both sides. And the square root of 9 is 3. So this means that there's two answers. One of my answers is positive 3, so x can be 3, and x can be negative 3. So my two answers are negative 3 and positive 3. two solutions. That means there's two x-intercepts. One of the x-intercepts would be at -3, and one of them would be at +3. So we have to remember that when we take the square root of both sides of the equation, we must include the plus and minus sign. Plus, minus. So anytime we do this, where we do the square root of both sides, we have to include plus or minus to show that there are two possibilities. Because 3 if you square it is 9, and -3 if you square it is 9. So that it happens anytime you take the square root of both sides. All right, example 2. So I said before, we're going to isolate the x squared. So we start by subtracting 16 from both sides. 16, not 6. So that gives us x squared is equal to -16. Then we would take the square root of both sides. Well, I got a problem here. I've got the square root of -16. It's not possible to have the square root of a negative number. Because remember what a square root means. It means that what number multiplied by itself equals -16. Well, it's impossible to multiply a number by itself and get a negative. Just look at it what it looked like before. X squared equals -16. What number squared equals -16? Well, none. You can't, because if this were a negative number, this would be positive. If this were a positive number, it'd be still positive. So you can't square a number and get a negative. That's not possible. So for this one, we would give the answer of no real solution. We're going to find out in the next unit there's imaginary solutions, but there's no real solutions for this. Okay, so we can't have negative numbers in a square root. All right, next one. Okay, so again, we're going to isolate the x squared. Our first thing is we're going to add 20 to both sides. And I get 5x squared, wrong color, 5x squared equals 20. Still need to isolate the x squared, so I'm going to divide by 5 on both sides. When I do that, I end up with x squared equals 4. Okay, so right here, we're going to double check to make sure that this is positive because I can't have a negative square root. So everything's looking pretty good right now. So now we're going to take the square root of both sides. And anytime we take the square root from both sides, we have to include the plus or minus sign. So what's the square root of 4? The square root of 4 is 2. So there's two answers there. X can be -2 and x can be +2. That's what plus or minus means. So our two answers are -2 and +2. That means it's one of these situations where there's two x-intercepts. One of the x-intercepts would be -2. One of the x-intercepts would be +2. All right, let's look at the next one. So for this one, we're going to subtract 25 from both sides because we're going to try to isolate that x squared. Now you might start getting ahead of yourself at this point and go, oh, there's no real solutions because I've got a negative over here. But we haven't taken the square root yet. And we haven't moved this negative 16 yet. So don't do it yet. Wait until it's time to take the square root. So I'm going to divide both sides by negative 16. And see when I do this, the two negatives are going to reduce each other. So I end up with x squared is equal to, that doesn't reduce, it's just 25 over 16. The negatives reduce, but these numbers don't. So I'm going to just put 25 over 16. Okay, at this point, I finally isolated the x squared, so I'm going to take the square root from both sides. Square root that side, square root that side. Now, when we take the square root from both sides, we have to include the plus or minus. So x is equal to plus or minus the square root of 25 over 16. We got a fraction here, but one of our rules for square roots, it's been a while since we've done this, but one of our rules is we can take the square root of 25 and put it over the square root of 16. So when the whole fraction is inside the root, we can do it like this. So we're going to get x is equal to plus or minus square root of 25 is 5, and the square root of 16 is 4. So I have two answers there. X can be negative 5/4, and x can be positive 5/4. There's my two answers. Negative 5/4, positive 5/4. All right, we got a couple more. So all of these are done like the first lesson where we had A values. It's standard form. We had A values and we had sometimes C values. But what happens when it's in vertex form? So the next few problems we're going to do in vertex form. Okay, so example 5. This is in vertex form. So it's the same basic process. We're going to add 49 to both sides. So I end up with x minus 3 squared equals 49. And so when it's in vertex form, I just want to isolate the squared portion. So this is the squared portion here because I've got x minus 3 squared. Now I'm going to take the square root from both sides. So I take the square root of this side and the square root of this side. Remember, every time we take the square root of both sides, we have to include the plus or minus sign. So I get x minus 3 is equal to plus or minus, and then the square root of 49 is 7. Okay, I don't have the x isolated yet because there's a minus 3 right there. So I'm going to add 3 to both sides. So I get x equals 3 plus or minus 7. Okay, now there's two answers here. We don't want to leave our answers like this because I can actually find the two answers. The two answers are found by doing 3 minus 7 and then 3 plus 7. So 3 minus 7 would be negative 4. And then 3 plus 7 would be positive 10. So my two x-intercepts would be at negative 4 and 10. All right, next one. We're going to add 3 to both sides. So that leaves us with x minus 6 squared equals 3. Okay, I've got the x minus 6 squared isolated, so now I can take the square root of both sides. Square root of that, square root of that. Square roots cancel squaring because they're opposite operations. So I end up with x minus 6 on this side. On the other side, I have to remember to do my plus or minus sign because I took the square root of both sides. Now, the square root of 3 does not reduce. That's the first time this has happened when we've been doing these problems. So I'm just going to leave it as the square root of 3. Yeah, and square root of 3 is 1.7-ish or so, because remember the square root of 1 is 1, square root of 4 is 2. So square root of 3 has to be 1 point something. I think it's 1.7, blah, blah, blah. It goes on forever. But anyways, so, approximately 1.7 or so. But we're going to leave it as a radical. We still have one more step, add 6 to both sides. So I'm going to add 6 to this side. I'm going to add 6 to this side. So that gives me an answer of x equals 6 plus or minus root 3. Now, root 3, I cannot write the number down. It goes forever. So I could write it down, but I'd have to round it. I can't write the exact number down. So in situations like this, I'm going to leave my answer here. Now, why did I leave the answer here? Well, because I didn't have a radical, so I could actually find these two numbers. Over here, I've got a radical. So without reducing it, I can't actually find the two numbers. Now, I could rewrite this a little bit to show you the two answers. The two answers would be 6 plus root 3. That's one of our answers. So this is like 6 plus 1.7, so about 7.7. And my other answer is 6 minus root 3, which would be 6 minus 1.7. So what's that, like about 4.3 or so? Okay, but I want the exact answer and not about what the answer is. So these are our two answers. But when we have a radical left over, I want you to leave your answer like this: 6 plus or minus root 3. But these are the two answers that is made up of: 6 plus root 3, 6 minus root 3. All right, we're moving on. On this one, I'm going to subtract 80 from both sides. You might be thinking, oh, no real solutions because I got a negative over there. Well, hold your horses, not quite yet. We've got negative 5x plus 2 squared equals negative 80. And then we're going to divide by negative 5 and get rid of that negative. So we are going to get a real solution here. So divide by negative 5 on both sides. And I end up with x plus 2 squared. And then 5 goes into 80. What's that, 16 times? And it's going to be positive because the negatives are going to reduce each other. So I get 16. Okay, great. Next, I'm going to take the square root from both sides. Square root that side, square root that side. Okay, the square root offsets the squaring because they're opposite operations. So I end up with x plus 2 over here. I don't know why I put the parentheses around it, just because I did. All right, and then over here, remember it's plus or minus because I took the square root of both sides. So plus or minus, and this one does reduce. It reduces to 4. Okay, I can subtract 2 from both sides. So I get x equals negative 2 plus or minus 4. You want to put this one in front. I know some of you are going to be tempted to put it in the back, or some of you are going to be tempted to put it between the plus or minus and the 4. Don't do that. It goes in the front. So we've got negative 2 plus or minus 4. So this is like this previous problem where the radicals are all gone. So I can actually pick out my two answers like I did up here. So I'm going to give the two answers. The first answer is negative 2 minus 4. That's negative 6. My other answer is negative 2 plus 4. That's positive 2. So there's my two x-intercepts, negative 6 and 2. Okay, over here I'm going to add 16 to both sides. So that leaves me with 2/3 times x plus 1 squared equals 16. Okay, I want to get rid of this 2/3. So the best way to do it is to multiply by 3/2 because the 3 and the 3 reduce and the 2 and the 2 reduce. So I'm going to multiply this side by 3/2. So on this side of the equation, I still have the x plus 1 squared. On this side of the equation, let's see, 2 goes into 16 8 times, and 8 times 3 is 24. So I get 24 over there. All right, now I'm going to take the square root of both sides. So when I take the square root of both sides, the square root takes away the squaring, so I'm left with x plus 1. I cannot forget to do the plus or minus. Now, root 24 is not a perfect square, but I can reduce the square root of 24. 24, remember, breaks down into 2 and 12. This is 2 and 6. This is 2 and 3. So I got a pair of 2's and then a 2 and a 3 left over. So this would be 2 root 6. And yes, if the radical reduces, you need to reduce it. Our last step is we're going to subtract 1 from both sides. And we get x equals -1 plus or minus 2 square root of 6. We're going to leave it like that because we have a radical like this problem up here. So if we don't have a radical, we're going to find our actual two answers. If we do have a radical, we're going to leave it like this. Now, these are two answers. Don't forget, this is two answers. It's not one answer. These are two answers. This is the answer of -1 plus 2 root 6 and -1 minus 2 root 6. If we had to, we could find an approximation of what that is, but we're not going to go that far. We're just going to leave it like this. So the answer is -1 plus or minus 2 root 6, which is two separate answers of -1 plus 2 root 6 and -1 minus 2 root 6. 2 root 6 is a little bit under 5. It'd be like 4.9 or something like that. So it's -1 plus 4.9 and -1 minus 4.9. Those are the two separate answers. But we're going to leave it, when there's still a radical left over, we're going to leave our answers like that. All right, my people, that was a little bit long. Sorry about that. I will see you guys later. Math hard. Bye-bye.